All right, guys, today we're going to be looking at imaginary numbers and how we can use them to solve quadratics. So, equations such as x squared plus 1 equals 0 have no real solutions. Right? They're not in our plane of existence. So mathematicians defined imaginary numbers to represent their solutions. So the imaginary unit that we're going to be using is I. I think I, imaginary, starts with it, is defined as the square root of -1. Okay, so if we were using that example, right, if we were solving for x, we would subtract 1 over, take the square root. So we get that imaginary number, that's square root of -1. Just can't really take the square root of a negative. This is useful in working with square roots of negative numbers. So a pure imaginary number is going to be written in the form of bi, where b is some number or is our real number, and I, of course, is representing our imaginary part of that number. We're going to be talking about complex numbers later on, in which we'll have an a value here. We'll say a plus bi. That will be our next lesson, and we'll work with those. But today we're going to be looking at just pure imaginary numbers, so just the bi part of that. So with that in mind, we can start simplifying radicals. Again, this is kind of based off of what we were doing the previous day. So we're going to be simplifying radicals again, except this time we have that negative under there, and we're going to take that negative out and represent it with an I. So let's get started with that. So number 1, we have the square root of -9. So again, we can kind of think of it as we have that negative. We can kind of pull it out just like we would any other perfect square. Say we have that -1 underneath the radical. We can represent that -1 with an I. Okay? And then the square root of 9 is going to give us 3. And we're going to treat that I just like any other variable. We usually want to put it behind our number or behind our coefficient. So in this case, we're going to have 3i as our solution. Right? 9 is a perfect square. We take out that negative, put an I, or replace it with an I, substitute with an I. Okay, so number 2, we have the square root of 196. If you don't want to have to write out that square root of -1 every time, just remember you have that negative. There's going to be an I attached. And I always just pull it right out front. To begin with, square root of 196 gets us what? 14. So we got 14i. Number 2. Number 3, square root of -5. So in this case, 5 is prime. There is no perfect square that goes into 5. So the only thing we can do to simplify this is we can eliminate that negative under the radical, turn it into an imaginary number. So we have I square root of 5. Again, we want to pull those numbers or coefficients out in front of our radical. Number 4. We have the square root of -8. So again, we want to split it into the biggest perfect square possible and our leftovers. And of course, we have that negative. I'm going to go ahead and just pull my I out front. So square root of 80 can be split into 16 and 5. Square root of 16 gets us 4. We have our I square root of 5. That's the square root of -32. What is the biggest perfect square that goes into 32? 40. So 4 goes into it, but 8 has a perfect square of 4 that goes into it. So we can go a little bit bigger. It would be our next step up. 16 2. we take the square root of 16, gets us that 4, have our I left over, and the square root of 2. And our last one, number 6, square root of 192. And again, if you don't know factors of 192 off the top of your head, you can always go to your y equals on your calculator. Take your number 192, divide it by x. We can look at our tables, second graph. And we want to scroll down until we find a perfect square. So 3 times 64, 64 is a very big perfect square. So 64 times 3 gets to 192. Of course, pull out our I. Square root of 64 is 8. I square root of 3. Okay. So that's our simplifying with negative under our radical. So now let's look at solving some equations. Again, very much the same idea, except now we have an equation. Number 7, we have x squared plus 81 equals 0. So in order to solve our equation for x, subtract our 81 over. So we get x squared equals negative 81. We want to take the square root. Again, anytime we take the square root with that equal sign, we always need to add in our plus or minus. Square root of 81 gives us 9. We also have that negative, so we also put in our I. So nothing a whole lot different than what we did last class. The only difference really is we have that negative underneath our radical now. And so we attach that I, eliminate that. So let's look at number 8. 2x squared plus 9 equals 1. So what would be our first step? Subtract our 9. So we get 2x squared equals negative 8. What do we do next? Divide by 2. So x squared equals negative 4. Then take our square root. So x equals, throw in your plus and minus. Square root of 4 is 2. And we have that negative, so attach our I. Okay. Not too bad. We want to do 9 or 10, or are we good on those? Let's do 9. So number 9, we got 4x squared. 15 equals negative 9. First thing we need to do, subtract 15. It's 4x squared minus 24. Divided by 4. We get x squared equals 6. Take that square root. So we get x equals plus or minus. Can we reduce the square root of 6? No. But we can take out that negative. So we're just going to get I square root of 6. Okay. Any questions? You want to do 11 or 12? 12. Okay, we get 2/3 x squared minus 1 equals 17. So first thing, add 1. Equals 18. To get rid of our negative 2/3, what do we have to do? Multiply by the reciprocal, so we're going to multiply by negative 3 halves on both sides. So that cancels that out. Just that x squared. So we're kind of thinking about this two different ways: 18 times 3 and then divide it by 2. Or I can take 18 and 2, I can reduce those both by 2. So 18 becomes 9, and 9 times 3 gets us a negative 27. Then we can take that square root. So x is going to equal plus or minus. Is there a perfect square that goes into 27? Right. So 9 times 3. Okay. 9 is one of those perfect squares. Square root of 9. 3i square roots of 3. Okay. Any questions on solving or simplifying radicals? Okay. The next thing we're going to look at today is new. Okay. We're going to be looking at powers of I. So when we're talking about I, again, we're talking about the square root of negative 1. So I to the first power is equal to the square root of negative 1. We're just going to keep that as simplified as possible, and it's just going to be I. Again, anytime we're dealing with that negative under the radical, it's just our imaginary number. Now let's think about if we have I squared, that means we have 2 of these. We have the square root of negative 1 times the square root of negative 1, or you can think about it in the square root of negative 1 squared. Well, if we have these two multiplied together, you multiply the numbers underneath the radical. So we have a negative 1 times a negative 1. Don't do that. So we have the square root squared. Those two things are opposites of each other. That gets you negative 1. Okay. So square root and the squared cancel each other out. You get that negative 1 value. Again, you can kind of think of that same idea happens there. We have I to the third power. Again, we have the square root of negative 1, the square root of negative 1, the square root of negative 1. We know that 2 of them is equivalent to negative 1. So we have negative 1 times the square root of negative 1. Or we can think of it as we have a negative I. So again, that square root of negative 1 is I. So we have negative 1 square root, or negative 1 times I, or negative I. I to the fourth power would again be square root of negative 1 times square root of negative 1, square root of negative 1, square root of negative 1. We know that 2 of them is equivalent to negative 1. So we have 2 sets. So we have negative 1 times negative 1, which gets us 1. Okay. So then let's continue on with our powers. We have I to the fifth power. So now we have 5 square roots of negative 1. Being multiplied together. We know 4 of them is equivalent to 1. And then we have that square root of -1 left over, which means we're multiplying it by I. So if we have 1 times I, what do we get? An I. If we have I to the 6th, we now have 4 and a set of 2. So again, 4 of them we can represent with a 1. 2 of them we know is -1 or not. So then what do we get? -1. You guys see a pattern happening? I to the 1st, I to the 5th, we get I. I to the 6th, I to the 2nd, we get a -1. What do you think I to the 7th is going to get us? -I. And I to the 8th, 1. Okay, because this pattern gets established, we can use this to then figure out any power of I. And the way we can do that is we have 4 options, right? So that means we can take any power that we have. So our next question is, what is I to the 15th? So with that in mind, we can think, all right, our power is 15. It means we're going to have 15 square roots of -1 times themselves. I can take this power and I can divide it by 4. Now I want to figure out what my remainder is. Am I going to have a 1, a 2, a 3, or no remainder? So 15 divided by 4, how many times can 4 go in 15? 3. And how many do we have left over? 3. So in this case, I to the 15th power is going to be equal to -1. Or -I, sorry. I dot. So we can kind of think about our powers, or these numbers. You have a remainder of 1, you're going to be left with an I. You have a remainder of 2, when you divide by 4, you're going to get -1. A remainder of 3, you get -I. And no remainder, or 0, you're going to get 1. So you can do that with any power of I that we come across. So number 14, we have I to the 62nd power. So if we take 62 and divide it by 4, what do we get? Again, we can do our long division if we want to. Takes that, right? 4 goes into 6 1 time. Bring down your 2. Go into it 5 times, we get 20. So we have a remainder of 2, meaning I to the 62 power is equivalent to -1. Any questions on the power of I? It's kind of different, kind of unique. And so the way we use that is whenever we multiply imaginary numbers together, we get different powers of I. So let's look at a couple of problems and the way they work. So number 15, we have 4I times 7I. We're going to multiply our 2 coefficients together. So 4 times 7, 28. I times I is going to get us an I squared. Remember, I squared is equivalent to -1. So we have a 28 times -1, or we get -28. So 16. We have -4i times 2i times -9i. So again, multiply your numbers together. -4 times 2, it's -8 times -9. So that's 72. With I times I times I, or I to the third power. I to the third power was equivalent to -I. So we have 72 times a -I. Or we can move that negative out front, so -72I. Are there any others that we want to look at?
Mhm.
18. So we have I squared, 3 squared times -8i squared. So first thing is we got these two things being squared, so we need to deal with that before we do our multiplication. So I is squared, so I squared. Square root of 3 squared, again, square roots and powers of 2 are opposites of each other, so we're going to be left with 3 times -8 squared, 64, and then I squared becomes I squared. Last thing, I squareds again are just -1s, so we can just change our signs to what is it attached to. So we have a -3 times a -64. So -3 times -64 is what? So 192, right? We have two negatives, so it becomes a positive. Any others we want to look at?